Hi, my name's Steve. I work with the Museum of Life and Science, and today we're bringing you a bite-sized engineering challenge called earthquake testing. So in the real world, engineers and architects have to deal with earthquakes, and so they have this real engineering challenge of making buildings resistant or resilient to earthquakes and the motion of the ground underneath them. And so we have this kind of testing activity for us to kind of mimic that experience at home. And so the materials that I'm going to be using today are toothpicks, some Play-Doh that I'm going to be using for joining my toothpicks together, and then I have an earthquake testing platform, and I've made this out of a Ziploc bag and water. And so this is a lot of water in a Ziploc bag, so you'll likely want to do this experiment somewhere where you can get wet. Like outside is probably a great place to do this, on a porch or just in your yard, where you can set up this up and it's okay if the water spills out of the bag. So what I'm using the bag to do is I can make this motion, which is actually really similar to the way that the earth can move in an earthquake. And so the way I build these structures, and I challenge you to build them however you can, find structures that are more stable than others, but the way that I'm building them is I'm using these little balls of the Play-Doh and I'm just sticking them on the end of the toothpicks like this, and then I can join more toothpicks onto them like this. I'm just gonna make a cube for this one. So now I've got one last toothpick to put in, just like this. And I've got a super simple building that I can test on my earthquake platform. And so here's my earthquake testing center, and I can just gently press on this and I get this earthquake motion. And you can see this structure is actually doing pretty well. I can get pretty serious earthquakes going before it falls over, which is really cool. Let's try my other one. I've added this kind of roof to this single story because I thought it might help it stabilize. It adds more weight though, so there's always things you have to consider and kind of trade-offs that you make as an engineer. And so sometimes you have to test and retest. And so I like the stability, but it does kind of it gets a little top heavy with this roof on there. So it seemed like that couldn't quite withstand the same amount of shaking as my square or my cube did. Let's try my other structure here. And again, this is just how I built it. I challenge you to imagine other ways of building these, make really cool giant towers if you like. Sometimes the physics of buildings is not as intuitive as you might think. Sometimes big, tall buildings can absorb the energy of earthquakes. So this one, yeah, you can see it's kind of gentle swaying that it makes, but if I get a big earthquake, oh, it falls right over. And so now I've got some structural issues with my building, and I don't know if I can even get my test again. So you might have to rebuild and reimagine your buildings, because at first, engineers, they start with a problem, they approach it, and their first solution may not always be the best solution. So they test, they prototype, they retest, they go through a design engineering cycle. They iterate their design process, and they come up with really cool solutions over time. And so I challenge you to do that. Enjoy earthquake testing at your home, and we'll see you in the next one.